Pharmaceutical Processing, in conjunction with Interfex 2018, presents Interfex Live.
Our last panel of the day, and in my opinion, probably one of the more critical, ironically, critical utilities. As a process guy and formulator for over 30 years, I can tell you, I've gotten burned by critical utilities more times than I care to admit. Right, so I want to put this in perspective for you. You walk into a facility, it's got 3 fluid bed dryers. Hey, it looks like it's going to have the capacity I need. Do you have the steam? Do you have the capacity? Everything's, oh yeah. Key thing was, can you run them all at the same time? Seems like nobody did that. Horsepower calculation. One problem, okay? That's what I'm saying. This is with critical utilities, okay? The methacrylic acid copolymer suspension, coalescence rate started to vary, right? We've been down that road. How about the compressed air systems? Anybody taken a look at that recently, or better yet, check the dryer? And my all-time favorite, we had just transferred a process into a facility quite some distance away. We airlifted everything in, we needed everything, looked great, we launched. Went down to do the post-launch, and I noticed they're taking the wash water out of the equipment and putting it in drums and sending it out. Turns out that nobody ever bothered to check the effluent system, nor did they check on the sewage treatment plant. So that stopped this as well as if Russ had totally screwed up on the formulation. So having said all of that, I'm going to go around the horn here. So we got John, we got Trung, Bob, and Tom, right? Okay, so we're going to go in that direction. So John, what are critical utilities?
Yeah, so it varies maybe a little bit project to project, but typically it's defined as really anything that is product contact or touches product contact surfaces. So for example, compendial waters, clean steam or pure steam. You mentioned compressed air, specifically clean compressed air. Process gases, CIP, and then also on the waste side, process waste and or bio waste.
So we'll go in order. All right, you're up.
I'm up.
Yeah. Okay.
Hey, same question?
Yep, same question. Everybody's
all right.
going to put their 2 cents in.
Okay. Well, really the only thing I can add is that it does vary facility by facility, and I believe he mentioned clean steam, Wi-Fi, things like that. We also run into regulatory issues with the waste, depending on the municipality. I'm in the state of Massachusetts, so they have weird regulations, let's put it that way. So otherwise, I think you covered it pretty well.
Yeah, from where I'm at, I mean, if it's a permit issue, you guys, to me, that's part of the infrastructure I'm going into. I don't have to, in other words, as a process guy, I don't have to get you on the phone and ask me if the lights are going to light. Okay? Okay, Trung, you're up.
I mean, it's more or less everything they stated, but I'd like to add that most of the critical system that are product contact that's excluding waste are validated system as well, that we would actually go through and validate all these systems for purity and cleanliness and all.
Okay.
And I think the other piece, just to add on to that, I think we captured all the critical utilities, but do you have robust monitoring and tracking mechanisms in place? So not only to see when you're outside of the spec, but do you have good alert limits, for example, when you can start to prospectively identify some performance issues that may not be, again, impacting the final product, but are an indication that the equipment is not operating as intended?
All right, Bob, we'll start with you. Everybody we're going to do this for a while just to see if there's anything else that somebody hasn't forgotten. And that's only because I've gotten burned many times from this topic. So let me ask you. So let's talk about baseline requirements for clean air, particle pressure, dew point, stuff like that. Let's start with around that at the pressure, clean air as a critical utility. What your take is on the baseline requirements for clean air from a particle, pressure, dew point, oil content, stuff like that. I mention it because, in the coding, it had created a product failure. I mean, consistent failure. So anybody, if you're not comfortable, just whoever wants to start. It's open forum, guys.
So what I've seen in most facilities where I've worked, you mentioned pressure dew point. Typically, it's minus 40 degrees C or Fahrenheit, and you achieve that with desiccant dryers. Typically, that's your best mode of doing it. And from a particle standpoint, the requirements there vary company by company. Current company I'm with, they require that the air be the same level or cleaner than the space in which it's being used. So if you're in a grade 7 space, particle requirements are that it has to meet that same criteria for both viable and non-viable in compressed air.
Okay, well, speaking about compressed air, Trung, so if I'm going to atomize a suspension for oral solid dosage form, what criteria am I looking at? I mean, that's direct product contact, right? So what has been your experience there?
So typically we would do minus 40 dew point as Robert mentioned, and then we also do 0.2 micron filtration before the distribution as well.
I got you. So the infrastructure on that, okay? So let me ask you this, Bob: is that stainless, copper, what? After we go through this whole thing, the question really is how's the place piped up? So we go through this whole, make sure it's exactly what it needs to be. What's your sense on clean air then? What is it, stainless, copper, what?
So typically coming out of the compressor we'll have copper, and at some point, usually when we transition into the clean room, we'll transition into stainless steel tubing. I think, some differences that can occur plant to plant is where you locate the 0.2 micron filter. At some facilities that I've worked on, we have redundant 0.2 micron filters. In the event that you have a failure, you have that safety of having a redundant 0.2 micron filter. Another key consideration with air and oxygen systems, obviously, is making sure that you're clean for O2 service. Any components that you have, even though they may say that they don't have oils in them, a lot of times we'll have oils. Make sure we do a sufficient purge prior to use and prior to any testing that we have.
John?
Yeah, so I guess one thing to add, I think the copper versus stainless debate kind of is cyclical. I'd say very recent installations, we're seeing all stainless just based on market conditions. They're pretty close in pricing right now, but I'd say both are suitable from a product process contact standpoint, but obviously inside the clean room it would be stainless like Tom mentioned.
It would just seem to me from if the firm we're dealing with is pretty cautious, the copper seems to be the least desirable, only because, God forbid, we get the moisture back in there. It's a place you maybe don't want to be. Don't know. Anyway, ADI components in the compressed air. So John, you want to talk?
That's probably a good one for John.
John? Tom? Whoever.
So ADI, it's animal-derived ingredient-free. Typically on gas systems, it's not as critical. We have some clients that requires it, but it really doesn't really apply. I think ADI is more tied towards process fluid systems. ADI, in case you guys don't know, it has to do with mad cow disease because of the elastomers and all that stuff that are used for manufacturing, for lubricants and all that. So that's a requirement that you need to get certifications for it, and it's a long lead item. It's very expensive, and for processed gases, air and all that stuff, it's really not applicable. But for like a process system, fluid system, it would be.
And I think, when starting a project, the key thing is understanding kind of the expectation of your stakeholders, and in this case, it would be your quality folks, because there is, within the same organization, you may have quality folks who have differing opinions on that and drive you to purchasing different components. Again, I think I agree with everyone here from a technical perspective. There isn't a risk in this application. I think it's just more perception than reality.
Yeah, so the one thing I can add is that also in a large facility, you may have thousands of tri-clamp gaskets, and you're not guaranteed that the guy's going to go take the non-ADI and put it in Wi-Fi, and then take something that may have been ADI and put it in the clean gas. So in a lot of cases, from a facility operability standpoint, they say all elastomers, all those components are going to be ADI free.
So that's pretty tough. I mean, if you got guys putting that down, I mean, we deal with it on the drug product side all the time, but I didn't realize they were hammering you guys as well. That's rough. While we're talking about it, seems to me that the distribution and the piping stuff. So why don't we spend a little bit of time on the old aspect, stainless steel? I mean, I couldn't tell you how many times, getting back to the old coating, the stuff's rolling around in bed, and I get the old black spots on the tablets. Always makes me very happy as a formulator. But anyway, let's talk about rouging and stainless steel, stuff like that. Who wants to lead off on that? John, Tom, Trung? Who?
I mean, I think rouging is a tough one because you can have systems identical application, but the development of Rouge can be very variable, and it's not always easy to understand the technical reason for that. I think the way that we've dealt with Rouge to date is, qualitatively we've observed things over time, and we've developed derouging cycles to address that issue. And it kind of, now our PM procedures, they're based off of what have we seen historically. A certain vessel, a certain clean steam, distribution header, makes sense to derouge on a annual basis or a once every 5-year basis. I don't know if you have any thoughts on that as well.
Similar. I mean, the facility I'm at right now, they're doing it every 2 years, derouging the Wi-Fi loops and the clean steam every 2 years. That's just, does it need to be done? Again, it's not a quantitative entity at this point. It's purely a qualitative assessment.
I know there's been some talk of trying to do free iron testing to kind of quantify over time, is the material changing? I don't know if you've seen that used successfully to date.
And we haven't implemented it. I've seen that there are some people with meters now, online meters, and then also you can do the testing. But again, the facility, the mantra has been, we're going to change the diaphragms and gaskets anyway, so let's just go ahead and do it.
Well, how does that compare to stuff like passivation and stuff?
So I think for at least the facilities I've worked in, the passivation is it's kind of addressing a bit of a different issue. So trying to maintain the passive layer of your stainless steel tank to prevent corrosion over time. So a lot of times that's application based. So if you're in a solution prep area where you're making buffers with high chloride concentrations, you'll want to do that passivation cycle relatively routinely so you maintain the passive layer. Whereas if you're with an upstream tank that never contacts chlorine concentration, that passive layer stays intact, and therefore there's not really a driver to run those passivation cycles.
Is that usually something that your partner or your client would do, that they generate the information? I mean, I've seen, where somebody wants to make ferric chloride, and all of a sudden, oh man, it becomes a big problem.
So what we've done in the past as the end user is, when we understand the bill of materials, we understand what we're going to make. If there's a high risk material, you can do testing with, firms such as Steris. We'll do stainless steel coupon testing. We'll try to understand from a chemical perspective what's happening to that passive layer, and based on that small scale testing, we'll develop cleaning regimes to maintain the passive layer.
Okay. While we're on the topic, all right, let's talk about that. So, what are the, hold on a second. So we talked about the rouging, we talked about the passivation, and the cleaning, that's where I was going. Right. So what are some of the typical, pitfalls on clean-in-place systems that you guys have run into? Obviously, this impacts on facility, water systems, the whole thing.
Yeah, so I think at a macro level, we've seen, actually very recently, we've seen a handful of facilities that are they're bottlenecked. So they're tied down by CIP cycles that run much longer than they were originally intended to. So whether things went off the rails during cleaning validation, or it was sometime during manufacturing runs, et cetera, something that was a facility that was designed to have a 3-hour CIP cycle is now a 17-hour CIP cycle. And you can see how that might affect the throughput of the whole facility. So that's kind of the, some of the macro level recent issues that we've seen. I think if you drill down into that, there can be a number of reasons for it. So it could be a design issue. Perhaps the tanks weren't sized appropriately. It could be a velocity issue. So if you're not maintaining velocity in the cleaning lines, it could be instrument tees that were in the vertical, not in the horizontal. So you're getting air pockets in there. It could be flex hoses that aren't sufficiently supported, so you kind of have a dead leg low point within the flex hoses. So there's kind of a whole lot that can go wrong with CIP that we've seen. And again, at a macro level, it can really bottleneck your facility.
And I think just obviously CIP design is challenging, but even when you get the design right, there's things that can go wrong. And at least in my experience, that tends to happen when you're running the facility in a mode that it wasn't intended. So, perfect example is startup activities. You're trying to qualify your different CIP cycles. All of a sudden, your diversity of the CIP skid is significantly higher than what it was ever thought to be, and then potentially your water generation system's not sufficient. An example on kind of the other end of the spectrum, if you think you have a high throughput facility, you're cleaning equipment often, you may have a large chemical storage distribution skid, right? You have lots of chemical storage, but if that facility is not heavily utilized, then you run into an issue where I have all this chemical, I'm not using it, and all of a sudden it's expiring, and then what do I do with this expiring chemical? So I think it's a lot of times, even if you have a well-designed system, if you're not running it as the facility was intended, you have a lot of negative impacts.
So centralized systems, I mean, CIP. So, I mean, how much does it knock on like the quality that I'm generating in the water side? I mean, that's got to be key as well, no? I mean, so in other words, how much does that play? So what I'm saying is, guys, I got a problem with CIP, but isn't that a knock on sometime? The way that the WFI system or the DI system was set up? I mean, what has been your experience? I mean, what do they use? The highest quality water, the least quality? Any comment? Yeah.
So we typically use a WFI for the final rinse. Depending on your water generation, on your infrastructure and all that stuff, like if you use a VC stove, we would use all the other detergent washers with a WFI as well, but typically it's purified water that we would use for the initial rinse and the caustic and acid wash and all that. I'd like to add to the pitfall to the CIP thing. When you're designing a facility and all that stuff, especially like a stainless facility, the majority of your water usage is from CIP. And when you design that, you want to be conservative, but you don't want to be overly conservative, because you cannot oversize your water system, because you want to maximize the runtime on your water system. So when we go into design, specifically a fixed your stainless facility, we project CIP cycles, usage, consumptions, and all that, and how often, when that recipe changes between design and when you're operating the plant, that's the pitfall that we run into with CIP is you're trying not to be too conservative with the design to accommodate the water, but because of your cleaning recipe not meeting the requirement based on your initial projection, to me, that's the biggest problem on CIP.
Sounds to me like the user's got to be a little more upfront on this stuff. I mean, for one of the problems I've seen, like you had mentioned WFI on the final rinse. I mean, I've seen that, and yet we come in same situation. All of a sudden, I see him emptying WFI out of bottles off a skid. Like, what happened here? So, obviously the generation system was either inadequate or not dealt with. But today, I mean, there's other options. So the WFI, like in the EU, they're doing the membrane filtrate. So where are we at on stuff like that? I mean, it just popped in my head. Anybody want to?
Well, membrane filtration. Right now, there are 3 pharmacopoeia that adopted membrane filtration. There's 2 other that still require distillation. Membrane filtration is very energy efficient. It's actually and it really depends on the temperature water you need, the quality, as well as your feed water coming in. So membrane filtration, the only concern with membrane filtration is the biologics that's tied to it, because you're basically generating water at ambient temperature where potential for microbial growth is pretty high. So you need to monitor your generation system rigorously and put in place a very robust sanitization sequence for that.
So, again, ambient, but that seems to be where you should be moving. But what I'm hearing is you got to bring everything else up to this stuff here. You know, the sanitization process, the whole bit.
Yeah. So you need to sanitize and maintain your system from microbial standpoint. But if you generate it ambient and all that stuff, there's a lot of energy savings that comes with it. But yes, you need to keep the system basically microbial free based on the WFI guideline. Go back to it.
So I guess a question I have for you, Trung. So, obviously with an ambient system, you can do periodic hot water sanitizations of the storage tank and the distribution tank in this mode. What are your thoughts on, similar like a PUW system, keeping the ambient tank ozonated? So as opposed to hot, keeping it ozonated, would that be a potential option that could be evaluated?
Oh yes, that definitely is. So ozone. So in Europe, highly purified water is actually WFI grade water that's classified as highly purified, and people would keep ozone in the storage tank to maintain sterility, and then do the distribution with like UV to take out the ozone when they're doing the distribution. But periodically they would basically turn the UV off to sanitize the distribution loop. So ozone is definitely an option for sanitization besides heat. It's a very effective sanitization option. But no one has ever done that in a validated WFI system.
So is the generation system coupled to the storage system? Maybe I'm missing something here.
It's not coupled.
So there's advantages to totally isolate.
Yeah, Tom was bringing out the heat sanitization portion of it on the distribution side.
Because, with an ambient system, if you have a hot system, it's self-sanitizing, right? So we need to figure out how to sanitize periodically an ambient system. So, obviously the disadvantage of doing a hot water sanitization of your storage system is it's going to take time. So it's going to bring your production line down for 4 hours, for example. But if you go with the ozonated approach, that tank, similar to a hot tank, it's always self-sanitizing. So you don't have the downtime associated with, you'll still need to sanitize the loop, but the frequency of that sanitization is less, and the total duration of that sanitization is less. So it kind of gives you kind of best of both worlds. It gives you the energy savings, but it also limits your downtime due to sanitization.
That's good. So that's what your experience has been.
No, I think it's we have, as Trung said, folks aren't doing it, but I think it's something that it's an option that's out there that probably should be looked at in a little more detail.
So that would be a recommendation if I was to come to you and ask you that question.
And I think the complexity obviously is, if you were doing a greenfield, you approach problems one way. If you approach existing facilities that has existing infrastructure, existing boilers, existing stills, you have to look through you have to look at everything holistically, economically, what makes sense, operations-wise, what makes sense.
Gotcha.
And they're different answers based on the situation.
Well, let's look at that. I mean, one of the things I've seen is people test themselves into oblivion. All right, so it's a monitoring. So you got the system monitoring. What's the trending on high purity systems? For example, how much is too much? I mean, to me, we always do too much. But let's get some feedback here. Who wants to handle that?
So I've got a little experience with this where we
Just
have
a touch, right? Yeah, okay, good.
So we have multiple Wi-Fi loops with online TOC and online conductivity. Yet if, let's say there's a diaphragm leaking and you shut the loop down to replace the diaphragm, you run a hot water sanitization, before you can release the loop back, QC has to give you the first read on endotoxin, and they have to give you the read on TOC. Rather than using, and they also do conductivity. So rather than using the TOC meter online to put it right back in service when you know it's good, you have to wait. And so it's that additional 4 hours of downtime. So I think that we have facilities where we've implemented analytical technology in line. It's just that we're not taking advantage of it. It's one thing if you just put it in and you've never had any experience with it, but I've in a facility now where we have years of data that says this is giving you reliable results, yet we still don't use it.
So nobody's ever correlated the two?
It's been correlated. It's just that from a
Wow.
release standpoint, there's inertia to get,
Well, there's
to
inertia and then there's stupidity. I mean, so the
And
question I
think-
have is, which is it?
Well, I think
Sorry.
to add on to Robert's point, I mean, it's not just, that's obviously an issue when you're, shutting down a loop and starting it up again, but we, still have routine offline monitoring as well as the online monitoring. So we have a tremendous amount we have staff testing costs that's dedicated to basically verifying what our online TOC, online connectivity is saying. So I mean, I think if you've qualified that your loop is, it's designed properly, you don't have any dead legs, you've qualified the performance of that loop with your offline testing, it really doesn't make sense to continue that testing because again, you're verifying continuously what you already know.
Okay. So, Trung, I mean, so it sounds to me like it's all about preventative maintenance. I mean, what is a typical program for a diaphragm system? It sounds to me like that's something we should be jumping on and hooking together with a monitoring system. What is a typical prevention?
Well, I think on that one, it's plant specific, it's application specific. Depending on criticality, usually the more critical the system, the more frequently you may maintain it. But I think one of the things that we're trying to move to generally is from time-based maintenance to performance-based maintenance, right? So as opposed to, it's been 5 years, let me rebuild that control valve, perhaps it should be, well, let me look at that control valve. Has its performance changed over time? No. Well, then I probably shouldn't rebuild it because I think we've all seen every time you go into a system, you add in a different risk, right? What if I rebuild the control valve incorrectly? What if my tuning parameters are no longer appropriate? So I think what I've seen is often if you have a system that's working well, there's a lot of benefits to not touching it and letting it just, again, continue to operate.
All right, so let me ask you this quick while we're on the topic. So we got the preventative maintenance. So what about the sanitization? I mean, is that something, what's a typical frequency on something like that? We heard about it, we got the monitoring systems. And so what is typically in the preventative maintenance here? The sanitization.
So it really depends on the client. I know that I've on ambient, like storage and distribution systems, I have 2 clients that basically do a daily sanitization. I have clients that backed off to 2-3 days. I guess it's more of less of a risk-based, like people don't want to take the risk when everything's working well and they're sanitizing and they've been running and all that stuff. But I think like everything else, I think we need to basically kind of step back and take some risks to see, because these systems are so robust that you really don't really need like a daily sanitization, but it really depends on the clients. I have 2 clients in front of me and I have other clients, and I can tell you that it's different scheduling between them all for sanitization.
And I think, Trung, the one thing I'd add is, so you need to qualify your sanitization frequency,
Yes.
right? And if you want to have a really aggressive approach to sanitization, you need buy-in early from QA that, yes, we're going to try to qualify this loop to run for 30 days without sanitization, right? But that's an investment into the loop, and people want your facility up and running fast. They'll say, well, you know what, that's a risk I don't want to take. I want to just do my 5 days or 2 days or whatever the case may be. And we miss that opportunity because once you're up and manufacturing, the appetite for change is low. So it's really trying to implement that more aggressive approach early on because, once you have a licensed product, licensed facility, it's very hard to implement change, no matter how good it is.
So you're recommending that should be built into the PQ/IQ cycle then? You have to do that proactively and push it out as far as you can. I mean, where's the benefit risk ratio there? I mean, is this something you discuss with the client or? I don't, why is it going to take me 30 days to bring this up and go online? And you know what I'm saying? If I'm going to get 30 days between cycles, that's way better. All right. So how do you put that out there?
Well, again, I think a lot of it goes client by client and what that particular client has experienced. So in some cases, you have clients who are dealing with 30-year-old Wi-Fi systems that have plenty of dead legs. And in order for those systems to meet quality criteria, they have to be hot water sanitized every day. Because if you didn't, they would not, you would start failing. So you have to get over that hurdle. And then the next step is you do have to have the time up front to say, we're gonna get the system commissioned and we're gonna run it for 30 days and we're not gonna sanitize. And then we'll sanitize and then we gotta run for another 30 days and not sanitize. Because they wanna see you repeat it. You can't just do it once.
Okay.
So the benefit is if you can move from a daily sanitization to a monthly sanitization, it's the energy savings and it's the downtime.
Okay.
4 hours a month versus 4 hours a day.
I get it, but I think the way maybe I'm reading between the lines too much. It also sounds like somebody's going to put a brand new Wi-Fi system in because the diaphragm is going to save us all this money, but they're not going to change their piping. Does that happen? I mean,
no. If you're gonna renovate a system and actually
Okay.
get rid of the dead legs, you're gonna do the piping too.
you would think so,
Yeah,
right?
it's just that they have you end up with people with experience that say, because I had this problem on an older system, I don't believe it'll work on a new system.
And I guess maybe to address your question more directly, why do people keep those 30-year-old loops in place? Well, it's because that capital cost is prohibitive sometimes, right? You can take that small operating cost each year as opposed to a $1 million investment to upgrade the facility.
Yeah, I got it. But again, that has to be weighed against everything else. One of the things is risk, and if the risk isn't there, fine. All it takes is one recall, guys, and all that saving we did is gone. So from a product standpoint, it's anyway. But I mean, who do you interact with in that case? You deal with quality people, you deal with development people. Who makes these decisions? Who do you have that dialogue with?
Yeah, typically, validation and quality. Yeah.
Operations, is that right, or just quality?
Operations would basically say, if you give me a system I don't ever need to sanitize, well, then I won't worry about doing it.
Right.
They'd be perfectly happy not to sanitize.
Okay, so then you go and argue with the quality guy then. Okay, yeah, I get it. Okay. Did I not hear, can we get back to the bio-waste thing? Maybe I misunderstood. So, I wrote it down. That's what I was here. Do we differentiate between bio-waste and process waste and from, sanitary? Can we get back to that one? I wrote it down and totally missed it here. I'm sorry.
So a bio waste and a process waste from a design standpoint, it's more or less designed based on like a plumbing system where we use, pitch piping with a certain flow, half flow, and all that. The main difference between bio waste and process waste is basically the material of construction, the temperature, and the waste that we collected that we need to treat, either to a biokill piece of equipment that kill any cell-based waste, and then we neutralize it before we dump it to sanitary. But from a design point on sizing and everything, it's exactly the same. However, like a lot of facility, when we design a facility, we build a facility and all that, and when we get the facility up and running, quite more often than not that we can run into issues with those systems with the local plumbing inspectors and all that. And that is because they don't have a clear understanding of these engineered waste system versus a sanitary system. They see a floor drain, they see a equipment dumping into a drain and all that, they automatically think that it's like a sanitary waste system, where in reality it is an engineered waste system that we need to, design it slightly different.
So we're talking about a system that goes with on-site treatment system, correct? I mean,
Yes.
Yeah, typically it has to go to some on-site pretreatment system before it can be discharged to the public works.
exactly.
So again, to his point, you run into systems where, or issues with the plumbing inspector saying, hey, you didn't put the vent in the right location because I consider it a sanitary system. It's like, well, the vent is in a location where the vent will work. You know, it will still function. Yes, it may not meet your sanitary code, but by your own plumbing code, it doesn't have to. It's a special engineered waste system.
Right.
So we end up doing things, we end up having to pull the plumbing inspector in and explain things to them, and ultimately just do it however they want. So.
Okay. Yeah. Sounds like a productive conversation. So, but let me ask you. I mean, customarily, again, you mentioned what I had talked about up front. I mean, it says essentially the problem comes in when you go into the effluent stream. I thought that's how the interaction. Sounds to me like it's upstream then.
Well, I think that on projects where we engage the local plumbing jurisdiction up front and all that stuff, we run into less of an issue because they understand that these are engineered waste systems, that it's designed a certain way. It's when we're doing a facility and we cannot provide that level of detail to the plumbing inspector for many different reasons that's not tied to the design of the facility.
So these on-site treatment systems, they can be over-designed or under-designed. Let me ask you this, is there a danger? In other words, this particular system, anyway, I don't keep going to go back to that. It was clearly under-designed. But if you over-design them, it doesn't sound like there's any advantage to that either, right? I mean, if it's too big, does it still do the job? I mean, if it's too small, it clearly doesn't.
So a thermal system that's too big is very problematic. But an undersized thermal system is also going to create a bottleneck for you. I think in chemical systems, probably a little more forgiving, so chemical neutralization of bio-waste, and then pH neutralization systems as well. I think you have a little more leeway there.
Interesting. So the other point, I think the other thing that we're going to get into, and it's a separate topic. So is there any other points we wanted to make about waste or WFI? I mean, did we miss anything? I think we kind of covered it. How about WIFI generation? I mean, is there anything critical about pressures, anything there that we need to consider that we didn't cover? I think we check our notes here. Well, yeah, there it is. We talked about clean steam. That was the one we wanted to do. We talk about that a bit? The clean, temperature, pressure, that kind of stuff.
I can.
Well, I mean, I think one thing that's important for clean steam is, again, understanding what your users are. And for example, if you have a bioreactor that has a double mechanical seal using clean steam condensate, that becomes a very critical utility that you can't lose. So then you take it potentially a step forward and you say, well, what's providing water to that clean steam generator? So in the event that you have, for example, a ambient W5 distribution system that needs to be sanitized at some frequency, that's really not going to work for this application because it's going to shut down clean steam condensate to your bioreactor. So I think, again, when you're talking about critical utilities, there is no set answer, right? Because everything is kind of interwoven, intertwined. You really need to look at how everything interfaces with each other to find that optimal solution, and it's going to be different on a plant-by-plant basis. I mean, in terms of clean utility, I'm sure you guys have experience as well, but I mean, you can use purified water or W5 as kind of your source material, and you'll have online monitoring of the pressure to make sure that you don't lose pressure within your distribution system. One of the things that I think we might get into in this session is around redundancy. Something that's important in the application that I talked about is, do you have redundancy for that clean steam generator? Because if you have a critical user that needs steam at all times, well, then you need to build in N+1 redundancy. But if you have a single-use facility where there is not maybe you have an autoclave, but you don't have a constant user of clean steam, well, then that requirement for N+1 redundancy, it kind of goes away. It might still be something nice to have, something the end user still wants, but it's not a requirement.
Yeah, to that point, I'm in a facility right now where we put in one autoclave, and that's the only user of clean steam in the facility. And we have one clean steam generator, and it hasn't been an issue for 2 years. But as we're fitting out the second clinical suite, we're putting in a second autoclave, and they want to go ahead and put in the second clean steam generator, even though it's not really needed.
So as we add to the process, we continue to add, one of the things that I think now people are more aware of, so the answer is, well, we need this, so we have to increase that capacity. Stuff takes energy. So let's do it, because we're going to circle around here now. So obviously you guys are aspects of critical utilities, but let's talk about powering these utilities. How do we conserve, we got to do we talked about the diaphragm, but in general, how do, what kind of energy conservation are we building into these systems?
I mean, I think, for all of us, energy savings, water savings, sustainability is something that's very important, and that's part of the reason why Trung was saying we don't want to oversize our systems, because if you have, for an example, a oversized W5 multi-effect still, every time that turns on and turns off, you have a significant energy waste. So I think there's definitely a component to initial design, right size things. Another important design component is having the right level of monitoring and trending in your facility. So do you know how much water you're using, who's using the water, do you know where your energy is going? And by having really robust monitoring and trending in place, that allows you to identify who's your energy hog, and then can you do anything to address that? Can you change can you put a VFD in here? Can you change an SOP to positively impact your utility use?
I think that's to me that's a really good approach, because I think in a lot of cases people always think that alternative energy sources are the way to save energy, so we'll put in a wind farm. That ain't the case. Look at what you're doing on a day-to-day basis. I mean, do you do this sort of review when you looked at processes? Obviously, we looked at the water system. What else? I mean, where else is the great opportunities here?
Absolutely, we look at all that stuff, and for like water generation, it's not just energy, right? Like, the more you run the equipment, the less chances of having microbial growth within the equipment. The more you run the equipment, the cost per liter of WFI goes down. There's a lot of factors that we look at when we size these equipment, and it ties between all the systems, like the clean steam generator, redundancy and all that, like the distribution pressure. Like, we generate a certain pressure, we run it, and then we regulate it by running it at a higher pressure and all that stuff. You minimize line size, you minimize the utility to get there and all that, you minimize the energy, the insulation, all that. So we take all these in consideration, because all these systems are interrelated in one way or another. Like, the CIP has such a tremendous effect on the stainless facility that it cascades all the other utilities that basically feeds that piece of equipment.
Right, but as we heard in the beginning, it can go from 4 hours to 18 hours. So.
I think one other opportunity on the clean utility side, not just energy savings, but in water savings. So if you look at RO reject, and if you look at still blowdown, there's a tremendous amount of water going down the drain in a facility throughout the course of a year. So those are some of the early conversations we'll have in a project as far as gray water reclamation opportunities for the site. And it really varies by the client's appetite, the local inspector and code, et cetera. But they are definitely things to look at.
Yeah, I mean, I know in facilities I've worked at, we've tried now some of that reject water, it's so salty you can't really use it, but there is some water that you can take. You can use it for tower makeup. So there's things that we're constantly looking for. How do we get the most out of every gallon of water we use? I was gonna say something else, just slipped out of my mind, but yeah.
Gentlemen, thank you very much. That takes care of our live session for today. Thank you.
Thanks.
Pharmaceutical Processing, in conjunction with Interfex 2018, presents Interfex Live.